Okay, so this time, if you remember, I implemented a while back this um, Tetris game, and basically the idea was to try and get it running on an Arduino board. But I think it will take a bit more time than just the single part to get it running, because I haven't done this before. So yeah, it's gonna be interesting to see. And yeah, mainly for today, what I want to try to do is I have one of these boards basically with an LED, and I was trying to get this thing to basically display something, like anything, basically lit up any LED on the matrix that we want. So yeah, then basically we'll be able to do the game. So yeah, I found this library, but it's for like using it in the Arduino. So not really convenient for us because the project was made in pure C basically. So yeah, the idea for today is to try and copy the functionality of this library pretty much. And yeah, but yeah, I mean, first let's try to do like some really basic stuff. For example, let's get an LED. I have one, and let's try to make it lit up pretty much. Let me just take some wires, and yeah, like just trying out the thing, I guess. So yeah, connecting basically the ground and plus. Then let's put the LED, like we can put it anywhere. And yeah, I mean, we put the short one, like the short pin is like the minus, whatever we want to call it. And yeah, I have this resistor. um, I mean, you can use this website to figure out the values. So yeah, I mean, but I have like a strip of multiple resistors, and it has the value of them on the stripe, so it's easier. And yeah, I mean, you have to now connect the negative to, like, makes sense to have minus to minus and plus to plus. Man, I cannot see that well there. But yeah, you basically want to connect it like this, I guess. Have the negative leg there, and yeah, let's use a longer thing. You can put it anywhere on the plus line, because it's like pretty much where you see like the red line, there's the connection, I guess. And yeah, if you connect it like this, it should lit up because it completes the circuit, right? And I mean, we can do some more interesting stuff, like this 13 pin is the one that flickers. So if you connect it, you cannot see it, but if you connect it to our LED, it should flicker itself. Yeah. And I mean, yeah, I mean, that's not really like, oh, we programmed Arduino or something, but yeah, like the basic stuff, right? Because we can use that to test the the things that we do basically. So yeah, I guess another thing that could be fun to try is to use a button. Let's see. So basically the button is pretty small, but the idea is, and you can click it, and like the idea of the button is that it connects. If you can see, wait, let me use another one to show it. It has 4 little pins, and it is like a rectangle. So it when you press the button, it connects the 2 lines between each other. And when it's not pressed, or like pretty much always, the legs that are further apart are connected, like the ones that look parallel to each other. So when you press the button, it connects the 2 lines on the breadboard that are parallel. So how to make this one work is we need to put a big resistor between minus and any of the pins. So let's say like this, and I use a 10k ohm resistor. So you put it between the leg that's closest to us and the negative, and then we can use another wire to connect the other leg, this one, to plus. And now if we press the button, we shouldn't see anything happening. It's not connected to anything. But if we take the wire that we had before, and now the idea is when we press the button, the current will flow. I think it flows like this, from through the red wire through the button because it's closed, and then through the resistor back to minus. And now if we connect the other negative leg, which is on the other side now, on the same side with the resistor, let's keep it on this side, and let's move the LED a bit, like from there to here, or doesn't really matter. I wanted to use another wire, but it's fine. And if we put this cable on the positive side of the LED, now when we press the button, it should lit up. And basically the current will flow through the red wire, and when we press the button, it goes through the button, through the orange one, then through the LED, and through the small resistor back into minus. So that's how it works. Okay, so we can use the LED to figure out when we make one of the pins on the breadboard or on the Arduino high. So in some way we can try to test our code when we start going at it. So we won't need a button for now. It's more like for the inputs to the Tetris game when we get there, but we'll see how far we can get today. So I guess now we can try to start. Let me just have this cable, I don't know, put, let's say we are gonna use like 8, 9, 10, 11, that sort of stuff. Doesn't really matter, 12 for testing and stuff. Oh, I put it in well, it's not programmed yet, so it doesn't know what value it can be, plus minus. Basically we have the Tetris project. What we want to do is to add this stuff there. So I've got an idea of how the chip on the LED matrix works. It's like a shift register, so basically we have 3 important pins on it. Well, I mean we have 5 pins, right? We have I think the first one is VCC, like 5 volts, then ground, then it should be data in, chip select, and clock. So I mean, yeah, and basically the idea is like on this page, clock will tell or I mean, I guess chip select is first. It tells us whether we want to load data or not. And basically when chip select is 0, that's when we can write to the registers. And yeah, we have data in, which is basically what data we write, 1 or 0. And clock, when the clock goes from 0 to 1 or the rising edge, it shifts data into this register. And yeah, basically we can connect multiple LED matrices in series, because they also have, on the other side they have 5 small pins on the other side, and it's like the same ones, but instead of data in, it's data out. So the bits that get shifted out of this one go into the next one. So yeah, that's how in theory it works. So yeah, so from the last time, I mean, doesn't even matter the old project, we have this new makefile, which is just gonna compile our tetris library. And if you don't remember how it worked, it was basically just an array of the pieces, right? So we tried to use as little memory as possible and no mallocs and stuff. So that was interesting. And yeah, we have just tetris spawns a piece, I think. Then tetris tick, which moves the piece down, and you can specify left or right to move. And yeah, I mean, the idea was that we have a board height, how many rows, and yeah, like from this one we control the size of the board. And yeah, this is the board, and basically we have to display this board on the LED matrix. So I mean, it would be easy to use this one, but I don't know if we can, so it's easier for me to just reinvent the wheel, but I think it's a good learning experience to do that. So yeah, and this is the hello world, I guess, for our Arduino. It's like setting the, I mean, even this one, it's a bit hard to explain if you don't know already. I mean, pretty noob at this, but got the main, like the basics, right? So basically we have this DDRB, which is like the data direction register, and using this you can do the stuff from Arduino with pin mode 13 output like this, but it looks uglier from C, right? Like this looks nicer, but this sets the pin mode, and if the bit from the DRB is 1, then it's output, and if it's 1, it's input. Okay, so that's the main idea. Okay, then yeah, pretty much the same as in Arduino is like pin set, or I don't know how you do it in Arduino, to be honest. Pin mode, let's see if ChatGPT knows. Digital write, okay. So we do a digital write high, and here we do digital write low, basically. So, I mean, it's the same thing as Arduino, if you ask me. Anyway, yeah, and this one is because we need to, if you remember, we cannot use the standard library on WebAssembly, so we had to expose it as a function that we have to implement. So yeah. Anyway, let's see how we can start on this one. I guess the first thing that I saw was the data structure, let control. So let's have this basically structure in here. So let's do structure let control. I mean controller sounds nicer. And basically we want these 4 pins, right? The int, I don't know why it called it SPI, but anyway, let's say LED, or I mean data in pin, chip select pin, and clock pin. We need these 3 pins, right? It also has max devices, or I guess int num devices, because we can put multiple in series. And yeah, I see that it has this status, which is what is displayed on the LED matrix, but we don't really need it because we have the board on the Tetris game already, so we don't care about that. And it has this SPI data, which is like a temporary buffer, which we can actually try to use. I mean, I think I would prefer to include std int, let's say, and use uint. I don't even know if it's correct to do it like this, but uint 8t is gonna be a temporary buffer, right? And I think we can do something like this. And yeah, basically the size of this buffer is, I think, 2 times the number of devices that you are gonna have. And it's basically just because, well, not in this file, but in this file here, when you write to the LED matrix, you need to put the opcode and the data. So it has like opcode and data. It's interesting how it works. So yeah. Then let's try to initialize this thing. So let's make an init function, I guess. I mean, we don't really need one, but void let controller init. But we don't really want to alloc this stuff. I would rather now have it as a pointer and then pass it in. And what I'm curious about is if we have this structure, the controller, and we do let controller init, and maybe, I mean, yeah, sure, whatever you say there, little bro. Let's do define data in pin. Let's say it's pb, and yeah, I mean, we can use this thing to figure out which pins to use, and we said like 12, 11, 10, so let's use pb4 for the data in. I guess, let me see, because let's put it in order so it's not. Let's use clock on PB4. So PB2 is gonna be this one. Let's do chip select on PB3 and clock on PB4. Okay, let's say the number of devices is 1 for now. And yeah, when we are gonna use the full Arduino, let's use 2 devices, right? Like, yeah, whatever. And yeah, now we can do a unit 8 buffer, and it's gonna be 2 times the number of devices, because that's how many temporary stuff we need, right? Yeah, it's like from 0 to max devices, it does something. So yeah, I think it's gonna be only 2. So in here, let's see if it works like this. It looks like it works, and it even compiles. So it compiled. Okay. So it can actually have this. Perfect. Then let's continue. So we are able to init it, and let's see. I would just copy paste this thing, because why not? Just take the opcodes, right? So let's see how we have to implement the init. So initialize all the stuff. Here we do some checks. We have to set the pin mode on this stuff as yeah, basically set the pins to output. So DDRB is gonna be something like this, right? Okay, then we have to put on the chip select, we have to put a high bit, because we want to tell it that we don't want to write anything. I guess that's the idea. So let's say something like deselect all devices. I guess that's how you. Well, if we write to CS, that's enough. So port B, yeah, we set it to high. Let's leave the comments. Why not? So this is like set the controller struct, deselect all devices. Then we don't have a status. We don't care about that. And we want to have this for loop now. Let's see what this for loop is about. So we go for int I, we go up until num devices, I++. Yeah, I'll be honest, I'm not really sure what this means. OP display test 0. So let's say send command, or LED controller send command, right? Like pretty much that's what this function is about. Okay, we have clear display shutdown, set scan limit. So we just have to try to implement this stuff. So let's say let's take the first one, set scan limit, because probably it's gonna depend on SPI transfer as well. So yeah, let's say like this. So it's gonna be a void set scan limit, and let's keep the names as they were, I guess, and we will change them afterwards. But for now, let's let's see something like this. So we take the address, which is the device that we want to change. We need to also take in the struct LED controller, and yeah, basically controller num devices. We just return. I would put something like that, and I guess the limit should be between 0 and 8. So yeah, it does that. Set scan limit. So yeah, like the main function is this SPI transfer. It's what does all the stuff. Then we need clear display. Okay, let's also copy paste this one. Okay, so yeah, pointer controller, and here let's do something like we did for the other one. If the address is not valid, we just return. Then we need this offset, which I think, oh, it's defined here. So we take this offset, and I guess we don't even need it. I don't know why, because here it was used to save it in status. But we do really care about status. And let's just send 0 straight up. Okay, so clear display just sends 0 for I guess each row, pretty much. 1, 2, 3. I guess that's what it does. Not sure though. It's like 1, 2, 3, right? And also 0. Oh yeah, it's like these 4 operations, but I'm not sure what do they mean. Op digit 0. My guess is that it's for writing an entire row or something, but not sure. And the last one is shut down. So let's see where shutdown is. Well, it's this one. So if I would have guessed, yeah, sure, there is a shutdown operation, so makes sense. So let's say we have this shutdown for struct LED controller, and we put a controller in here. So uint uint 8. We're gonna use we're gonna use an int for the boolean value. Okay, here we have this thing, and let's maybe have something like int value, something like that, and then we use just value. And I think that's all there, but see, it needs to be a byte. So let's do uint 8. And I mean, we can change more stuff, like for example, this can also be an uint 8. This has to be an uint 8 to make things nicer. Again, uint 8. I don't know, I could also be a uint 8. Something like that. For shutdown, I see it's the same thing, because we use the address. Well, the address is an int. So, but yeah, like address probably is not used in. Well, anyway, let's keep it uint because like, let's keep it unsigned character for, let's say. So yeah, basically now we need this SPI transfer function, which we will again copy paste, and SPI transfer should also take in the controller, obviously. Take in the controller. Okay. And even here we need to take in the controller. Shutdown 1. Well, I mean, I'm sure I'm gonna make this thing nicer when I'm done, but for now let's just LED controller struct. Sure, makes sense to just now try to change it. So this is uint 8, also uint 8, because we want to just make sure that it works. Right. So yeah, now we make use of our buffer. So here we are gonna say something, create an array with the data to shift out. Oh, it's basically this one, I guess. So controller buffer equals 0, and I mean, yeah, it should work. Okay, put our device data into the array. So device, we want to SPI transfer into a specific device. Let's do uint 8. So here we are gonna do something like controller buffer is opcode and then data. Like as you see, we put data and opcode in our thing. So yeah, now we have to enable this thing. So what we want to do, well, we don't really know which port we are using, so we might also need that. So let's say I was just curious what is, so in init we use DDRB, but we should use we should have like volatile uint 8 pointer to the port, and I think we also need, well, yeah, the port and also to the data direction register. So we also need this. So let's put them here. So, oh, not there. I wanted to put them in init. Where is init? It's here. So let's do volatile. Yeah, let's put them like that. And here we have DDR and port. And basically, here we need to say something like this, actually. And when we set the port, we use this one. right? And inside of this we need to put the address of DDR B and the address of port B, right? So that's how we are gonna control which port we use. So now we have to say something like this to make it low, to enable the line. Then we have to implement shift out because shift out is made in Arduino, so we need to do that. And here we need to latch the data onto the display by making the chip select high. Okay, so yeah, we need to do shift out now, and let's do shift out for most significant bit. So let's do void shift out MSB first. And what does it take? Let's copy this thing. So it needs, it's gonna need data, clock pin, data pin, and I think it also needs a port. So it's gonna need tile uint 8T port. It's gonna need uint 8T data in pin, clock pin, and data. So let's see what it does. So it goes for I equals 0 to 8. Okay, I think it looks okay. So it takes, I have no idea. So let's do something else. Let's do uint 8T mask. It's gonna be, I would say it needs to be like 10000, you know, something like that. So let's do uint 81 shifted to the left by 7 basically. But we can even do something like from I equals 7 up until 0, and here we need to get uint 8 mask is gonna be 1 shifted to the left by I. Then we set the clock to low, right? Then we have to see what value we write in the port. So it's gonna be it should be basically we do an AND between the data and the mask, right? And then we set the clock to high. So I think this is how we shift out a byte. Something like this. Yeah, we take the most significant bit, we send it, do clock low, clock high, and here we do the AND. So yeah, I think that's how we do it. Okay, so here we need to shift out the data in this order, I guess. So from the last one, so we shift what? The opcode. And I mean, to be honest, I prefer to do it like this and not have to do here -1. So yeah. Interesting. So in this one, SPI transfer, So I was just looking at it because it looks like, oh, I get it. It's pretty neat though. Well, no, I don't get it. It's like we make the buffer 0 for everything, and then we put just the data for the LED matrix that we want to change. But then when we shift out, it means that, well, yeah, we don't necessarily delete the other ones. We just push in more data. So if we always SPI transfer into the first one, like into the first LED matrix, we are gonna just shift all the other data. So yeah, pretty much that's how it works. Would be nice though to have something like, yeah, I don't know, to be able to, push. Yeah, I don't really get it why it's like this. Because yeah, you cannot really say. I mean, maybe this is what status could be used for, but let's not think about it too much. Yeah, anyway, so this is like LED controller send a command, pretty much. LED controller set scan limit. This is a clear display, I guess. This is a LED controller shut down, and then we have the init. So yeah, I think everything looks fine. We just have to do like set, I don't know what set digit does. Anyway, set column, set row. Let's try to do set LED, and then let's see if we manage to set one of the LEDs. So basically this is gonna be LED controller set LED, and here we are gonna have uint 8t for the address, uint 8t for the row column, and the state. So first of all, yeah, we need this check to do something like, and I forgot about the structure here. Struct LED controller star controller, and here we need to say that if we have the address is not right, we just exit. If the row is not correct, although since we have uint, we kind of get rid of the negative cases, that's, I think, nice. Okay, so then we get this offset, but that's just for the status, so we don't care about status, I said. Okay, so let's see how we actually do it. So this thing is basically specifying the column, right? So it's gonna be, I mean, it's the same as doing value equals 1 shifted to the right by 8, let's say like this, and then shifting it to the other side. So we can actually do this thing, shift it with 7 minus column, right? So if column is 0, then it's gonna be like this, 1 0 0 0 0. So yeah, basically that's the value. So it's gonna be an uint 8, uint 8t. We don't need offset. Let's remove this. Okay, so then what we actually need to do is to yeah, well, here it, oh yeah, that's why we need the status, because if we just say set LED, we don't know what is on that row, so we are gonna delete everything else. But let's just do it like this for now. Right, let's just do it like this. LED controller send command, so it's gonna be controller. We have to send in the address, and the value. But yeah, I mean, that makes sense now that we might need to have the rows. So we'll add that, because as I said, for us the board is going to be the state, but we actually need the state, right? So let's actually try to, I mean, we don't use the state here, but yeah, I'm gonna do it after we test it. So let's not do anything like this. Let's still keep this one, but let's change it to like 2 seconds of staying. Change it to like 2 seconds of staying on, I guess. So let's see. We need to just init it, so it's initialized. And I mean, if we just set the LED here, LED controller set LED, if we set the first one to, no idea. This is how we should do it, I guess. So let me just now connect the LED matrix. So we need to put, okay, let's take out the breadboard for now. Let's just move it there. And yeah, now we need to connect the LED matrix. So I mean, let's see. We need to put, I mean, I don't know how to connect it, to be honest, but let's put like ground first. And 5 volts, I think. Yeah, I'm not sure why it flickers, to be honest. Let me just check. So I said clock is gonna be PB4. PB4 is 12. Okay, so we go from 12 to, I mean, we could stop the Arduino just to not see anything going wrong, you know. Then we have to connect chip select to PB3. So it's this one, it's 11, right? And we need to connect data in to PB2, which is 10. So yeah, basically like that. And yeah, I think that's how it should be connected. So let's see if I plug this one in. and we try to build. Okay, anyway, we get some warnings, but and here we say mega.copy, but we need to do sudo to copy it. So yeah, let's see. I mean, I guess it did something, but not sure what happened. So yeah, now it's time for debugging, I guess. So that's gonna be fun. So, like, we did the init, and I copy pasted it, so it should be alright. And yeah, I mean, as I was saying, maybe it would be worth to see what happens on the breadboard by using some other LEDs. Uh, mhm. Yeah, well, I mean, I was just expecting it to work first try, but no. But yeah, maybe it's wrong on doing the set LED like this without the state. So maybe we actually need the status for everything. So let's see where status is used actually. But I mean, it feels a bit weird to have like the status. Maybe, I mean, maybe we can try to implement it in another way, like because we don't really care about setting the LED. We care more about flashing a matrix to the LED matrix, right? But I thought that this could have been like a good test to try it. Let's check the warnings maybe. So it's just about the zero comparisons and the state here because we don't use it. We're going to shutdown mode on startup. So do we need to let's check the examples because I saw that here are some examples, or I guess they are in here. Demo. So let's see. So in setup it does shutdown false, intensity, and clear display. So let's try to do this. So we do init, and when we do init, wow, I scrolled way too much. It does shutdown 1. So we have to then do LED controller shutdown 0, then set intensity. Well, we don't have intensity, so we might need to implement it, and we need clear display. LED controller clear display. So let's also copy paste the set intensity. So we can use it, so LED controller set intensity, and we're gonna have struct LED controller pointer controller uint 8t and uint 8t. So here is this thing, the intensity, and basically we need to send this command. So yeah, for the intensity. Perfect. So now we can actually set the intensity, and in the example it's set to 8. So let's just do it like that. And then, I mean, does some stuff. It does some stuff, but I guess oh my god, you see that? We got fucking real right now. We are so back, dude. Holy shit. That's what I'm talking about. So, and now things are getting real. Oh my god. The bad thing is that, dude, like, I don't get it. Like, I recorded for like, what, 40 minutes or something on the phone, and it went from 50 to 20. Jesus Christ. I mean, yeah, we'll see. I have to be quick then. So, yeah, I guess the thing is nice. We might need to add the status, but it's like really annoying to me because yeah, like if we now try to do, so how does it work? It's address row column. So if we try to do the next row, it shouldn't really be a problem, right? It puts it on the next column. But if we try to do the same row, it's gonna overwrite it. So if we do the same row, it's gonna be overwritten, right? So that's the issue. That's why we need the status. But I was just thinking, well, we don't really care about setting one LED. We want more to be able to get an entire matrix and flush it on the LED matrix, you know what I mean? So basically that's the idea. Or maybe having like set a row and give it a number. So let's see how this guy made set row. So let's not have set LED individually. Let's have set a row. So LED controller set row. LED controller pointer to the controller, and here we're gonna have the classic uint and the byte that we are gonna write. So we don't need the status. We are not lame. We are just gonna write in the value straight up. So let's put some stuff like this, and here LED controller send command. So we also need to send in the controller. Perfect. So yeah, now we can actually just write an entire row. So LED controller set row, And let's do something like, I don't know, something weird just to see it. So yeah, actually we get that. It's pretty nice, pretty cool. So yeah, let's actually try now to go into Tetris. Well, let's go into main.c, see how I well, bruh, shut up, man. Anyway, is game over. We don't really need that, so we just need to create a Tetris structure. Let's make it here. Let's remove the extra stuff that we did. Tetris init, so we need to include tetris.h, and now we have the structure, right? And inside of this while loop I was doing like tick, so let's tick this, right? And the movement was defined, I think, somewhere real random, but I don't remember where. Oh, it's here. So let's do move none. Let's not do any movement right now. We do tick. Then I was doing this mem compare between temporary and board. So let's also take this. Let's have a delay at the end. So let's do this mem compare. Okay, and let's have is game over. Basically, yeah, I don't really care about when game is over. We just need to restart. So we'll see how we are gonna handle restarting. Like we cannot break from the while loop. So yeah. So board height. Let's see. So let's do here if not defined, because maybe we want to make it smaller, but the board buffer should stay the same. So now here we define the board height to be just 8, because we have only one. Well, I mean, yeah, doesn't matter. Include, can I use string.h for memcompare? I think so. So basically that's everything, I guess. Yeah, I mean, if game over, I guess we could not necessarily break, but do like you would have to have another do while. I was thinking just to lit up some LED, but let's just not do anything in case it's game over. So that means if we copy this thing, well, it didn't work or what? When I oh, I forgot to do the most important stuff. So we basically need to go over the board. So for something like this, and let's remove this function because we are not gonna use it. So we have to do just this. So let's see if we build this and we copy it. Okay, I guess it's 1 second delay, so maybe it takes some time. It doesn't. Yeah. So I guess didn't really work. Sad. So Tetris spawn. The board. So I mean this one should be fine, and even tick should work. I don't see why it wouldn't work. So let's see here. LED. No. Let's not display this. Let's try to display. I don't know, like. Let's do a Tetris spawn, and let's try to display like on the first row, and here we should use maybe 8, 9, or is it 9? I think it's fine to do 8. Well, it depends though. I was thinking to display the shape. So we need 9, 10, 11, but on separate lines. So here let's not do basically anything. And let's see. Okay, let's try 0B. Pretty weird. I mean, let's try again to show 1. Okay, so it displays it. But it's strange that the board doesn't have anything, even though I do Tetris spawn. Because we even implemented rand int. I mean, what? Well, I guess we could control rand int to always return 0, for example. Or I mean, let's make the board be always 1, right? So if we don't even need to do this, it's gonna be full of 1s on the first 4 rows. But it's not. Well, I mean, I meant to say it's gonna have a 1, but wait, what? Interesting. Let's do at least only 1. Yeah, what? Anyway, let me just try to do the board 0, and let's put something inside of the zero board. Like I don't really get why it's not showing anything. Because it's clearly like the board is unit 8. So it should have some stuff in it. But it's so strange. Wait, what? Why doesn't it like when I call to this thing? When I call to see like it, does it like crash somewhere? Even if I just define the structure itself? No, then it's fine. So it crashes on this one? What? How does it crash on it? I mean, anyway, I can initialize it with 0 like this, but I don't get why it crashes, or what happens there. Okay, let's do DDRB. Let's enable output on pin 13, and here let's do port B, and how about doing this? Doing a XOR, like making it flicker, right? Yeah, so now we can see, like, I guess if it crashes, then it would stop flickering, right? Because I don't get why it stops. Maybe it somehow messes with the memory of the AD controller for some reason. Let's put it first or something. Yeah, what? So scuffed. I don't get why it was not liking this. Pretty weird. I guess then if we found some kind of problem, let's try to go back to something that we had earlier. I don't even know where we need to go, like maybe 10 minutes ago or something. No, it was maybe something like this. So it doesn't like that. Yeah, I mean, I have to figure out what the actual problem was. So here we need to do some kind of for loop, and LED control set row the board. Okay, so let's see. Okay, still doesn't like this. Mm, I mean, let's try again. 0b 111. Yeah, I don't really understand why it's not liking the Tetris game. So yeah, whenever I do this kind of memory addressing, I see that it's stopping that. So I don't know really the reason. So yeah, let's try to change the board 0, or I guess like this, and try to put it there. Okay, so this actually works. And if we try to do Tetris tick, and let's put the movement is 0, and let's put this at 1. I mean, it doesn't really matter. Let's go. Yeah, see, like when I do this kind of memory addressing, it stops working. No idea why. Let's try to make it a global variable. That always fixes issues when you have them. Nope. Yeah. Um. Strange. Do we need to use that volatile stuff? For addressing, I guess. Like maybe it's. Oh well, I said that. Well, if I do it. Yes, it doesn't work. So let's see if we add here volatile, and I guess in this one and also this one. So it should be tetris.h. Oops. Like maybe when you do stuff with memory addressing, you need volatile or something. Just so that the compiler doesn't touch it, or I don't know what the reason is. Or maybe we just have to allocate it manually. Yeah. Okay, let's see in the example if it's. You can't really tell because it's in C++, but yeah, I mean, I guess, yeah, because the battery on the phone is running low. That's annoying. So I need to keep in mind that for like 1 hour I need 50%, so maybe 2 hours is like 100%, obviously. So yeah, I'll be honest, I have no idea why the that messes with volatile, why it messes with this. So I guess the other thing is in send command and everything we don't really, and we don't even need to make it volatile, but or like pointer, but let's keep it as a pointer for now. Let's just try to add this. No idea if this could fix it, but just throwing stuff at it. So this one, let's see. Nope, doesn't do anything. Yeah, I mean, pretty much no idea. So without that thing, kind of works, right? But there is a problem when we do memory addressing, so that's something we need to address, basically. Yeah, but I'm not really sure right now how to do it. So, I mean, let's at least do something like tetris spawn. Let's spawn a piece there, and then let's try to display it. So for int I equals 0, actually board, yeah, 0 up until board buffer. Let's show, actually, yeah, on row I we need to show board height plus I. So let's see if this thing actually will show us a piece on the, nope, it doesn't show us a piece. Okay, that's weird. Let's then put it in place. It is occupied. Let's take the pieces. Yeah, not sure what the problem is though. And here in the dot, yeah, let's see, at least let's try to get a piece. Whoops, redefinition. A piece is 2. Here we need to say piece is 2, piece is 2. I don't know if you can say external stuff. Wait, this, even this doesn't work. What? It's from 0 to board buffer. Ah, damn it, you know why? It's because I think the board is reversed, but still doesn't matter. So, yeah, like, let's see. I remember that the board is upside down, basically. Yeah, the board is upside down. But that couldn't really be the problem. Because if we try to do here tetris spawn and we pass in the t, it still didn't work, right? Or was I stupid the entire time? I was stupid the entire time. Oh my god. But if we put this one here, oh my god. Okay, and I cannot go back. Okay, anyway, so let's go into main.c. Hopefully I still have some time, because yeah, I totally forgot about that. The fact that it's going to be in reverse order, so that was my bad. So I don't think it matters then if it's volatile or not. So what we need to do now is a for loop, something like this, but we need to go from board height plus. So let's look into how we did tetris print, right? We did it like this, from board buffer up until board height, and we need to set the row for, so I is the row basically, or the line. So from board buffer up until, okay, let's see if this thing does anything in terms of like at least showing the pieces. Still doesn't work. Okay, let's spawn a single piece here, and then let's not do this man copy. Let's just do tetris stick. Let's keep this thing volatile or something, and let's see. So we don't need this tetris stick. So I'm not sure. So basically 0. Wait, I even forgot how I made it work before. So it was for int I equals 0 up until the board buffer. So this would be just that. Let's not do anything then. And let's try to see again the piece. Okay, so it shows the piece, right, from 0 to board buffer. So what if we try to do this thing inside, at least see some pieces, right? Random pieces at each second. Let's see if that works. Okay, so we see the random pieces. That's pretty neat. Okay, so then ticking should actually work. Right, we go from I mean, let's do another one. Let's do a tetris spawn, right? Then let's do a tick, and then do another visualization or something. See if this changed anything. Oh well, we still need to wait a bit, right, before we show it. Oh, I meant to make this and now make a copy. So it should see a piece and then the piece moving, but we don't. So it looks like, I mean, it's still a problem with the tick. Yeah, for some reason. Still some problem with the tick. But yeah, I mean, for now I think I'll leave it like this. because probably the recording will crash any moment. So yeah, but yeah, we have the pieces, and I have to figure out how to make this stick work because yeah, something went wrong. But yeah, pretty nice to see that it actually shows something on the display. Okay, so as a quick update, I actually managed to get it to work, and yeah, I guess basically what I did was to put the variables as global variables, and this fixed it. So yeah, I guess now I mean, it does the Tetris thing. So and I charged the phone a bit, so we can try to do something more. So let's actually try. Mm, I mean, adding input would be a bit too difficult right now, but I was thinking let's try to make it reset when you lose at least, or something like that. And that could be interesting. So yeah, basically we have this is game over, and what we want to do is to clear the display pretty much and reset the Tetris board. So let's see how I did it in main.c. So yeah, I would say game over. Oh, and it just exits. Okay, so then we are on our own. So basically, if is game over, we need to Tetris init the board. Just go from the beginning and also clear the display, I think. Although that's gonna be done automatically, but let's just try it. And yeah, basically now let's see what happens. So I'm not sure why it goes like that. I thought that I made board height 8. It's a bit strange. Board height is 8 and board buffer is 4. So I don't know why though it goes like that. That's like the only thing I have to figure out. Maybe I did something wrong inside of tick because I was doing board height plus board buffer minus 2. I have no idea why I have here minus 2, to be honest. Yeah, I really have no idea. I have to watch back the video why I did that. Anyway, board height plus buffer minus 2. Yeah, pretty strange why I did that. Okay, anyway, let's say I do it like 12 as it was before, right? It was 12. And here I say plus 4. So we start from board buffer, and here we do another minus 4. So it's like we are not gonna see the top 4 rows, but we're gonna see the bottom part. So I can see what happens when it goes. Like maybe I hard coded something for 12. Yeah, I think I hard coded something for 12. Let's go into main.c And inside of main, let's try to define wow, my board height. Let's try to define board height to 8, right, in the CLI version. So if we make and try to run the CLI version, something scuffed happens. What? I mean, I did if not defined, so that's pretty weird. I see, like if we do the bottom part, it handles it fine. So probably I hard coded something somewhere and I cannot remember it. But that's pretty weird that I hard coded it because I had these variables, so there was no reason to hard code it. And the only place where I could have done it is inside of tick. You see, like the stack smashing detected. Okay, so I really hard coded something then. Really curious what it was. Should we search for a 12 inside of the project? Because even if I try to put here 16, like, oopsie, what would happen? Oh my god, it goes to 12. Okay, I really did something wrong. I really did something wrong. Let's try to make this one, if not defined. Like, okay, so I did something wrong, like, but why? Because if not defined, right, then define it. How is this not right? Like, yeah, that's quite strange. Right, shouldn't it take it from here because this is what imports it? I'm really confused about this one. Maybe it's because of the order of the compiler. So let's go into make CLI, and maybe it's because we compile the tetris.c files first or something like that, something stupid. So, but I mean, we do CLI objects here first. Let's do make clean and then make, and let's try again. So this is for 12, I guess. Wait, what? It was 8? No, it looks like 12. Maybe I forgot to make clean and make again. Yeah, no, it's it just doesn't get it. So let's go inside of tetris and do a printf. percentage d board height. Let's just do, okay, and we have to include stdio for that. Well, it's not gonna work for some stuff, but we delete everything anyway. Oh my god. I mean, it could still work, so let's go into main.c, and after the init, let's do an exit 0. So wasm doesn't work, but we don't care about it. So it's 12. So it means that for some reason, even though we do the if not define thing, it doesn't work, which makes me really confused, to be honest. Right, like it's pretty strange. Anyway, let's see. So if board height is not defined, then we define it. That's the main idea. So let's do something like going to CLI. I guess this doesn't work. Wait, I thought, anyway, let's go back to tetris.c and let's remove the printf. Okay, we don't have anything. So now in the makefile for CLI, let's do something like when we build the tetris, let's define the board height equal to 8. Can we do that? And then remake it. Now if we run this, okay, but see, it's another issue now. Yeah, and to be honest, I thought that I knew my my C, like with the defines. That's really weird to see how it works. So let's put this one in compile flags. Let's see what it thinks about it. What this guy thinks about this one. Yeah. Tetris H. See, like now it's defined. Anyway, that's strange. So now it works. Yeah. Yeah, I don't know how to make it work. So make. Oh, let's go into main.c inside of this one, and let's remove the -4 and +4. So now it should be fine. Make @mega build and sudo copy. So now we should have just on for yeah. I mean, that's annoying that we cannot have the define like here. Yeah, but at least now we have some part of the game. We can try to do something like for the movement. Let's say if random tetris random int, and let's put here 2 is 0, then we move left, otherwise we move right. So let's see what happens if we do some random movement. Wow, it's and it looks cool. Yeah, I mean that's pretty nice. I'll let it play out until it loses or something. Obviously, it would be nice to have, let's say, uh, like 7-segment display to show the score. That would also be interesting. Come on, get at least one. But it's gonna be hard to get one by moving randomly. It needs just one. And it lost. Oh my god. Not even a single point. Okay, I mean, now, yeah, this looks like a much better place to end this one. So I guess the issue was that I had to do global variables. I have no idea why, to be honest, but that actually fixed it. And the other issue that we have right now is this trash defines. I don't know how to make it work from the code. So yeah, but it's not really an issue. That's not a big deal. The only thing that's annoying is that we have the number of devices, and then we could have defined the height based on the number of devices. It would be like 8 times the number of devices, right? So that's the only extra thing. So yeah, next time let's try to actually do another LED matrix and have like a larger game, and also add inputs, I guess. So yeah, we'll see from there. Basically, that's the plan. So yeah, I guess now it looks much better than when I first stopped. So yeah, I guess that's all for today. So see you next time.